I'm laying model railroad track in industrial areas for flawless operation on Ron's Trains and Things right now. Hi, I'm Ron of Ron's Trains and Things, and my model railroad layout is down to just 3 or 4 small areas of industrial track left to lay, and I'll have all of my track laid on the layout. Now, it's really easy to get to this point and to get in a hurry. The main line is all laid, and it's easy to think that this track isn't quite as important that it be absolutely perfect, absolutely bulletproof, as much as the main line is. But the fact of the matter is, these industrial tracks are where the switching takes place. There's a lot of action there, and you don't want a lot of derailments or other kinds of problems in these tracks. So it's important to take care to make quality track work even in these industrial areas, especially when you have areas like where I'm going to be working today, where there are lots of turnouts and short sections of track. Well, today I'm going to show you some tips about how to lay industrial track in order to provide flawless operation in your switching layout. So let's go get started right now. This video is brought to you by Midwest Model Railroad. Now with 15,000 square feet and one-day shipping, they truly are your one-stop model railroad shop. MidwestModelRR.com, link in the description. The area where I'm working today is Trinity Railcar in Saginaw, Texas. I've had the track arrangement settled here for a while, along with these 2 key structures, but it's finally time to get this industry laid and wired and operating. I started by moving all of the extra stuff out of the way. I then began fitting all of the track together into its final configuration. This meant finding the right pieces of scrap track that will work for some of the shorter joints here without introducing extra splices. I then cut these pieces precisely to length, making sure each rail was exactly the length it needed to be. For this, I used a pair of Xuron rail cutters that I use only for this purpose. They are perfect for track cutting, and if you don't have a pair, I highly recommend them, and I'll post a link to them in my Amazon pick of the week in the description below this video. I prepped the rail ends by filing away any burrs left from cutting. Check and file the rail head and the bottom of the foot of the rail, and also file a bit of the corners of the ends of the rail as well, as it will aid in installing rail joiners. Many people cut the last tie off of the end of track like this to allow for rail joiners, but I prefer to use a number 17 chisel blade and scrape off the track spike detail to allow the rail joiner to simply slip between the tie and the rail. This greatly reduces the need for adding replacement ties later. I do the same on the ends of the turnouts. As I prepped each piece of track, I installed rail joiners and fit the assembly together. I should note, as you can see on the far left of your screen, that this trackage is being laid directly on the plywood sub-roadbed, while the track leading up to it in this area is on cork roadbed. Long before laying this track and off camera, I sanded a smooth, gentle transition in the cork to the height of 0 where it connects to this track. Getting a smooth vertical transition is one important factor in reliably operating track. Vertical curves can cause cars to uncouple. I'm also taking time through this process to make sure that each rail joint is smooth to avoid bumps in the track that can derail cars. When the entire track assembly was together, I pulled it loose from where it connected to the existing lead. I considered taking it to my workbench and soldering the entire assembly together and then installing it in one piece, but I decided it would be easier to piece it together in place. Beginning with the connection to the existing lead, I disassembled and installed 1 or 2 track components at a time. I glue my track down with simple, inexpensive latex caulk. It holds well, it takes paint well, and it takes glue well. I usually use gray to ensure that it'll never show under the ballast, but on this day I had a partial tube of white already in the caulking gun from another project, so I just used it. For each track piece, I mark where I needed adhesive and I lay a bead of caulk. For the turnouts, I use only a spot of adhesive directly under the frog. I then spread the caulk to a flat, thin layer. I normally use a putty knife for this, but on this day, this scrap of styrene was handy and it worked just fine. When I had each piece in place exactly as I wanted it, I soldered the joints. I apply liquid flux only to the outsides of the rail at the rail joint, then apply a hot soldering iron and quickly add a bit of solder. The trick here is to have your soldering iron hot enough to make the solder joint quickly, not staying on the work long enough to melt the ties. After finishing each pair of solder joints, I use my NMRA gauge to check the track gauge through the joint. If the ties did get too hot, it will narrow the gauge of the track slightly, which can cause derailments. If the track is only slightly too tight, I carefully apply some outward pressure on the rails, which usually does the trick. If you have a joint where the ties are severely damaged, you may have to replace the entire section of track. You'll also note that I use this little mirror out of a makeup compact with a scrap of 1x2 glued to the back to help me see while I work on the back side of rails. I also use a straight edge to help me get the track alignment right through the turnouts and to get straight track truly straight. As I finished with each section, I drove some push pins into the plywood to hold everything in place while the caulking cured. I checked the joints for smoothness on the railhead and clean up any stray bits of solder with a bright boy, burnishing the rails with a steel washer afterwards to heal any scratches in the rail from the bright boy or from the file earlier. The next day, when the caulking had cured, I removed the push pins and began installing DCC feeder wires. I drilled a hole through this water bottle lid and left it on the drill bit to protect the track from accidentally dropping onto it as I drilled through the plywood. I then started drilling holes for the feeder wires. I drill on the outsides of the rails as close to the rails as I can get. Even power routing turnouts are not the greatest conductors down the track, so I install feeders on every side of every turnout. In this industry, that meant 8 pairs of feeders in a short amount of track. I vacuumed up the sawdust and started feeding wires through. I use 22 gauge solid hookup wire. I like to feed my wires down from the top and then pull them to length under the layout and connect them to the power bus before soldering them to the track. I leave enough length above the layout to let me strip the ends of the wires. I use these self-actuating wire strippers as I don't have to pull on the wires to strip the insulation away. Let me pause here for a moment to say if you're enjoying this video and if you find it helpful and would like to see more model railroad tips, tools, and techniques, then be sure to subscribe down below and click the little bell icon so you can catch future videos. With the wires stripped, I used a smooth jaw pair of needle-nosed pliers to flatten the end of each wire. I then bend it 90 degrees toward the rail. If any of these hooks are too long on the horizontal end, I clip them off with a pair of side cutters. I want just enough of a hook to catch the edge of the foot of the rail for soldering. Be careful to clean up all of the small pieces of metal as they can wreak havoc on your locomotive motors. I push the wires down through the hole in the sub-road bed, bending the wire toward the rail as I do until the hook just catches the foot of the rail. I then use a microbrush to apply a drop of flux to the wire and the rail and solder it to the rail. Again, a hot iron, quick on, just a bit of solder, and quick off is all you need. If you're in need of good soldering iron or accessories, I have my entire soldering setup in an Amazon list, and I'll link it in my pick of the week in the description below as well. I again check every soldering location with my NMRA gauge, clean up any stray solder off the rail heads with a bright boy, and burnish the rails to heal any scratches with a steel washer that is epoxied to this scrap of plywood. I test all of the joints and solder points with a piece of rolling stock to make sure everything runs smoothly. Finally, I used a bit of denatured alcohol and an old toothbrush to clean excess flux off of the rails. This flux will prohibit paint adhesion and if your flux has any acid to it, and some does, it will corrode your rails over time. Personally, I recommend acid-free flux for all model railroad applications. I tested the track with some mock operations with a couple of locomotives and some rolling stock to see that everything was running smoothly. Clearly, the electrical conductivity needed a bit of help, so I cleaned all the rails with a bit of mineral spirits, my track cleaner of choice, and then applied a bit of no-wax to all of the railheads. Then, everything was running smoothly. I am confident that these tracks and this industry will operate virtually problem-free for many years to come. If you'd like to see more about laying curves, turnouts, and other track, as well as other model railroad content, check out the links on your screen. And be sure to take a look at the Amazon Pick of the Week in the description down below, and join me on Tuesdays as I bring you even more great model railroad videos, and I will see you on the next video. 10, Lizzie?